Chapter 3, Number 9. Find the x and y components of a position vector r of magnitude r equals 88 meters if its angle relative to the x-axis is 32 degrees or 64 degrees. As usual, we start with a sketch. It isn't that important that the sketch be all that accurate because we're just going to get numbers on it later anyway. And our sketch sort of follows that, where we have the vector itself, and it breaks into x and y components by making horizontal and vertical legs. Then we can use some trig, and we say, well, for instance, the sine of the angle is the opposite over the hypotenuse, or y over r, which tells us that y has to be r sine theta. And similarly, we would have cosine of theta is adjacent over hypotenuse, which is x over r, and we can solve that by cross multiplying by r. We get that x is r cos theta. And then all we have to do really is plug in our numbers. So I'm going to get myself some more space. I guess I'll go up to the top here. I'm going to say for x, we have, in part A, we have 88 meters times the cosine of 32 degrees, which comes out to be 74.6, keeping really 75 because of the sig figs. So I guess we should pay attention to that. Oops. 75 meters, of course. And we get that y is 88 meters times the sine of 32 degrees, which turns out to be 47 meters. And that's part A. Part B, exactly the same kind of calculation, but we say that x is 88 meters cosine 64 degrees, which is 39 meters, and y is 88 meters sine 64 degrees, which is 79 meters. Maybe the most important thing to notice here that Walker didn't point out explicitly but probably wanted you to see is we've doubled the angle, but we do not double our answers. Neither sine nor cosine are linear in the angle. So be very careful about assuming that something's twice as large just because the angle is twice as large. In fact, that really only works for things like sine numbers very close to 0 degrees.